Hi everyone, welcome back to our channel. Today we are going to find the y parameters of the following pi attenuation circuit, and we have to draw the y parameter model. This is what the problem given to us. Let us try to understand. So before writing, let's try to write down the standard form of the equation. So we have I1 I2 is equal to y11 y12 y21 y22 multiplied with v1 v2. So what are the equations we're going to have is I1 is equal to y11 v1 plus y12 v2 is one equation. Second equation is I2 is equal to y21 v1 plus y22 v2 are the two current equations. Now in this model, when you see here, how I am going to take the current is I1 current is entering. Okay, so I am labeling this current as some I3, and I am labeling this current as the current in this branch as I1. So what is the voltage at this point is V1. So this is short circuited, automatically this will be voltage V1, and this is already short circuited. The voltage at this node is V2, automatically this also will be shifted to here. This is V2. Now I'm going to apply Kirchhoff's current law at this node. At this point of node, I'm going to apply the Kirchhoff's current law. So to this node, what are the entering currents? I1 is the entering current, leaving current is I3 plus I4. So in this equation, when you see here, how to write down I3? The current I3 we want to write down, so we should not disturb. I1 is already there, and that's why I'm writing I1 as it is. How to write down the current I3? V into Y. So what is the V value? V. What is the how to write down I3 in this branch? So how to write down the current I3 in this branch is voltage at the node is V1 and admittance is YA, plus how to write down the current I4. The current flowing, this is I4 current. So how this current is flowing is high potential is how much voltage is moving. So high potential is V1 and this is low potential. What is the leaving point? Minus high potential minus low potential divided by, sorry, into YB is one equation. Okay, now let's try to represent in terms of only V1 and V2. So M1 is equal to, I'm taking V1 as common, so there's nothing but when you take V1 as common, this is YA plus YB is one term minus V2 into YB. So compare with this equation, I1 is equal to y11 v1 plus y12 v2. So when you compare, y11 value is ya plus yb, and y is minus yb. So now we got the two values. So similarly, I'm going to reconstruct this network. So I'm now considering the output port. So I'm redrawing the network. This is V2 and this admittance is YC and this admittance is YB and this admittance is YA. Okay, so here we are applying some voltage V1 and the current is I1. So now I'm taking this current as the reference. This is I2 current. This will act as a current Ix and this will act as a current I. So now apply Kirchhoff's current law at this node. So when you apply the Kirchhoff's current law, what you are going to get is, so entering current. What is entering current is I2. So I2 is the entering current. Leaving current is, what is the leaving current in this branch, which is Ix, and next leaving current is Iy. So this is short circuited and this is short circuited. The voltage at this point is V1 and this will also be symbol here. Here we are going to get V1. The voltage at this point is V2 automatically. This will also be shifted here. All are of zero polarity. So now I2 is entering. How to write down Ix? So I2 no need to disturb. You need to disturb only Ix. So how to write down the current? Ix. Ix is equal to V2 minus 0 multiplied with the admittance, which is Yc, plus how to write down Iy, the current in this branch. That should be in terms of only V1 and V2. So high potential is current is leaving. What is the leaving polarity of the voltage? Plus V2. And this is the, so current is flowing in this like this. Okay, high potential minus low potential, V1 minus V2 minus V1, high potential minus low potential, multiplied by YB. Okay, so now this is how we got it. So now let's try to, sorry, this is YB. Why? Because this node resistance. So now I'm writing the standard equation. I2 is equal to minus V1 minus V1 YB, and in this equation I'm going to take a V2 as common. So when you take V2 as common, this is YC plus YB. When you compare with this standard format of equation, so I2 is equal to y21 v1 plus y22 v2. So the equations are, is one equation, and another equation is, so now let's try to write down in a standard format. So y11 y12 y21 as well as y22. Y11 is ya plus yb, y12 is minus yb, next y21 is minus yb, y22 is yb plus yc. This is very very important. Okay, so let's try to check it out how it comes and how it occurs. So here y11 means this is a sum of these two branches. So y11 is the sum of these two branches. And next y22 is nothing but output driving point admittance, is the sum of these two yb plus yc, and these are diagonal elements, and this is called transfer forward transfer admittance. So this is reverse of this value minus yb, and this is also minus yb. This is how we are getting all the y parameters. So now how to represent, what is the question asked? Draw the y parameters, find the y parameters of the following circuit we have been find out, and obtain the y parameter model. First let's try to write down the original y parameter and let's try to resubstitute it. Okay, so already we have the standard equations. These are the standard equations. For this standard equation, we'll write down and we'll substitute the values of I11. So how to write down the current I1? So this is a voltage source V1 and the current entering is I1. So this voltage Y1 will be there, and input port we are going to write down like a branch, and this value we are going to call it as Y11. And this is a port which is there in output port side. So for this we are going to represent with an a dependent source, and the current is flowing down with a magnitude of y12 v2. So this already discussed. If you are unable to understand, please refer the previous video lecture on how to represent y parameter equivalent circuit. So this is a voltage v2 is there, no, voltage dependent. What kind of source? Current source. This is how to represent this. So this current let us mark as ix, and current as iy. Similarly, this also we are going to mark. So the output current we are representing. So this is v2, and the current is I2. And what is the self admittance? Here we are going to have a self admittance of Y22. What is the voltage magnitude? V2. Okay, and this is one current, mark this current as MIX, and there is one more element which is referring the input port. So, but it is there in output port. How to represent a output port in terms of input port is use a dependent source and represent the arrow mark down, and what is this value is y21 v1, and this is iy. So join input port and output port, this is the equivalent circuit. Now what is the value of substitute this value? Y11 is ya plus ib, and y12 you write down as minus yb v2 value, and y22 value you replace as yb plus yc. And how to replace this value is y21 is minus yb v1. So therefore the resultant equivalent circuit will be like this. So this is a dependent voltage dependent current source flowing down with yb, current is flowing down. The magnitude of this is minus yb v1, and one more admittance where y22 is yb plus yc with a applied voltage of v21 I2. So this is the equivalent circuit model of a y parameter circuit. So this is how we have to obtain. So this is a step-by-step procedure. We have to understand. First, you have to apply the KCLs at input port and output port. You have to represent I1 is in terms of V1 and V2, I2 in terms of V1 and V2. So before going this, you have to remember this original equation, and you have to apply, and first draw the equivalent y parameter model and substitute those values. So this is how to obtain y parameters, and you can see here all the units of all y parameters are mhos. It may be diagonal or half diagonal. These are same. So hope you are able to understand. If you are watching for the first time, just write down the given question and find the answer. So if you feel the content is useful, please like and please share with your friends. And if you have any doubts, let me know in comment section. I will answer. And if you're watching for the first time, this is a free channel for the development of students. Please kindly subscribe to the channel which will help us to do more videos. Thank you for watching. We'll meet in the next video. Yours Ram.